Oh, I'm going to do a quick presentation on the data mining clustering. As you can see from my left here, I'm opening the repo. And in this repo, I'm going to explain the code that I put together to elaborate this assignment. And from the beginning of the code, I'm going to explain what are the libraries. I imported the libraries and the parameters, and also the binaries to be able to illustrate or to establish the correlation, association rule, and clustering among the credit card information that's a critical data set that I'm using. And here, as we can see from line 14, I'm using this to find and eliminate any or to find any missing data, any missing value, and also import the binaries and libraries for machine learning to be able to establish the correlated correlation between all the component that I need to fulfill this assignment. So as you can see, this is where I have my data set, and then I went down after the data set. Now I went down to define the reprocess function. The reprocess function, I have to choose the cluster type. The cluster type, now I have to build the k-means function to generate the output. Once we run through the data set, so the output, this function, the definition of the build k-means is to generate the output by going through the summary of the columns here, where we have balance, purchases, cash advance, payment, credit limit, and full, either low or high full payment. And also we have the summary to give. And then I define here another function, which is association rule, where we can identify the top rule for that data frame and the output. And from there, I will define the behavior of the purchase, whether it's a low or it's high. I define that, and also save the cluster with the all metrics from here. And as we can see here, axis, which is talking about the elbow curve, cluster K, and inertia. So those are the things that we are going to see on the plots. And the silhouette cluster and the silhouette score by K, we're going to see this also in another screenshot or another diagram plot. So from there, now I define here to save the heat map, and the heat map is going to be like a type of summary for whether I'm going to talk about the average behavior and the behavior of how the data is being used. And from there we can see the function to save the plot, and write the summary of this function, write summary as a function also. And it can lead us to the output directory for analysis. And this is the main function where all the function defined will pass through to whether give us the final output. And that output we can see from here as this output. When I run my code, this is the output I'm going to get. But this is very huge, but I don't know if I can add it to the assignment, but I will try. So it's right here. This is the output. And in this output, as you can see, you will see that I show already the balance, the purchase, cash advance, credit limit, payment, and PRC full payment. So in first place, I only show cluster 0 and cluster 1, the data and the data stream here, and how the top association rule is implemented here. You can see installment purchase high off, which is lead to as a consequent, you can see the support that is in, and the confidence and the lift. All these are being defined in the code. As you can see from the code, all these are being defined in the code at some point here. As yes, you can see PC1, and you can see silhouette, clustered silhouette. You can see elbow. This it is being defined. So yeah, this is going to be the output. And the association rule, I use this type of data to define the association rule. And as you can see, we have a colon 2 consequent, colon 1 antecedents, and the orange one we have colon 3 support. We have a colon 4, uh, colon 4 colon 4 to support, uh colon 4 we have a confident also, and the colon 5 lift. So all these are being represented here in the outputs, as you can see. But I will try to add this to my report in my assignment. So that's the data and the association rule. This also is I already added this. This is the representation of the top association rule by lift. So this is the k-means for the cluster projected with the PCA. So selection, and then this is another data to define the silhouette, dash diagram. And the silhouette diagram is right here, as you can see from here. So, and the heat map is like the summary of the whole entire process that I went through to maintain or to implement the strategy of using the machine learning to implement clustering, association, and correlation analysis. So that's it, and this is the data. And the run outputs, like I show. Now here, I try to put all the 3 clusters I defined. So this, I already added this to my assignment, as I will be showing it soon. So you have a cluster, we have a cluster 0, and the data, yeah, so you can see the comparison. We can compare step by step or one by one. We have cluster 1 as this, and we have cluster 2. So the summary of this, which is the top association rule, I'm going to put a little comment in my worksheet about this. So this is how I implement my strategy for this assignment. And coming down to my assignment in itself. So I defined the problem, and then I said that in this project I will be describing the three different data mining methodology by using clustering, association rule, and correlated analysis. So in this, I show the meaning of the clustering. I show the strength and the weakness. The weakness and the association also, I show it, which is used to find occurring events, and it helped to identify or to maintain the strong basket in the inside, and correlation, or help to determine how strong variable change together. So that's it. So coming down to the algorithm part, this is the core execution flow, which is just a little type of the code I put here. And in this script, as you can see, I mentioned every little things down. That this data set critical was read. It's going to be read through this with this code. You read it, and it give us the same data, same critical data set. So after we have this ID and missing value, so these are the things it's going to be looking for, and we get all this. So the k-means was scored in this category, and as I show, I'm going to show all this through the steps. This is one of the report that the result that I already show. Oh, I forgot to show the code execution in here. So let me go to the terminal, and so I can show you the execution part of it. So here I need to enter my data clustering folder. So as I'm in here now, I think I need to run this Python code. Yeah. So I'm running the code now, and we are going to see the output. So let me just pause the video here when the code runs, and then I will resume to explain it. Yeah, as you can see, the code runs successfully. As I already show this, I already recorded this in the first place, but I want to show the code execution, that you know that the code that I put together is working properly as expected. So as you can see here, missing value handled with the median imputation. I already showed this because I already took this to my summary report here. In first place, as you can see, is the same result I'm getting here, but as my terminal was not that big, so yeah, as you can see, it's right here. So I'm going to add this screenshot to my to the result, to the output, or to my worksheet. So that's it. As you can see, I already explained this cluster 0 and 1, and gave the installments purchase high or low or whatever. So I already explained this. So let's go back to my worksheet. So this is it, and I talk about the top association rule, reveal that here also, and I was able to add all these uh, screenshots about the diagram, the plots, and analysis of finding. In analysis of finding, there are three ideal customer the segment that can be acted upon. So we have a cluster 0, we have a cluster 1, and we have a cluster 2. And I explain it very well here. So this is the end of my presentation. Thank you for taking time to watch, and I'm very open to any feedback that may come out from it. Thank you again, Professor, and yeah, thank you.